So just going over reciprocal circular functions, what they are and how to sketch them. So the three reciprocal functions that you're interested in, reciprocal means 1 over, okay, so the three that we're interested in is 1 over sine x, which is called cosec x, 1 over cos x, which is called sec or secant x. We just use sec x because it's easier, and 1 over tan x, and that is in longhand it's called cotangent, but we're just going to call it cot. So cosec, secant or sec, and cotangent or cot. So for the first one, let's look at sine x. We know the basic form for sine x from our unit circles. Remember that we're going around this way for our angle. Sine of 0 is 0, okay, and as we progress around the circle, remember that sine is the one that we associate with y, so it's the up and down. We go from 0, then we go up to 1, okay, so that's at pi on 2. Going around to pi, which is over here, we're back again at 0, no vertical. Then again, continuing down, we get down to -1, and then all the way back to 2 pi. We're back at 0. So we know sine. We know cos works the same way. This time cos is x, so remember that for cos, we start here, and that's a length of 1. So we start at 1. When we travel up, we don't have any horizontal movement there. We're actually on the y-axis, so that's an intercept. That's a 0. Keep going around. Over on this side, we're at -1 for x, so that's why we go down to -1 at pi. Again, continue around. We're at 0, and then back again to 1. So that's our familiar cosine graph. And for tan, tangent's an interesting one. What it actually is representing, and I'll do this in yellow, is a tangent line, which runs like that. And it is where your angle actually hits the tangent line. So pi on 4, which is there, it's a 45-degree angle, actually hits the tangent line at the same height as the unit circle at 1. So that's why tan of pi on 4 is 1. Tan of 0 is here, it's 0. So for this graph, tan of 0 is 0. As we increase our angle, we get bigger and bigger and bigger until we get to pi on 2 here. Now at pi on 2, we would actually be drawing a line straight up, and that would be a line that runs parallel to our tangent line. So that's why at pi on 2, we actually have an asymptote. So we get bigger and bigger, get to an asymptote. Now we go to this side and our line goes down here, which should be in a straight line. So we can see that we're intersecting at a negative tan value. So we actually start really big negative. We continue around until we get to here where our tangent intersection will be 0, and that's at pi. So pi is there. So the way I've marked these off, pi on 2, pi, 3 pi on 2 and 2 pi. Again, once we get around, we're increasing our tan, so that's why I've increased here, until we get to 3 pi on 2, where we've got that parallel line again. So 3 pi on 2. And then again on this side, we're going to be negative, so it's going to go like that, up. Okay, so we know that, we're familiar with that. For the inverses, let's just do those ones quickly. For cosec, okay, cosec is 1 over sine x. Because it's a reciprocal, what that means is any time that sine of x is 0, we are not going to be able to have this function. We won't have any values. We're going to have an undefined area. So when sine x is 0, and that happens in 1, 2, 3 places, we're actually going to have asymptotes for the reciprocal because we can't have 1 over 0. 1 over 0 is a problem. So that's why we're putting our asymptotes in. Okay, and because it's a 1 over function, what that effectively does is it flips what you have. So rather than having something small to bigger to small, we're actually going to go the other way. Big is going to intersect at this point and come back up. The reason it does is that at this point here, pi on 2, sine of pi on 2 is 1, and so 1 over 1 is 1. So that still stays the same. Same here, this is small, but it's actually, in this case, going to be flipped over. Big, intersecting at that same point and down again. So the reciprocal has this sort of funny shape with asymptotes. So that's cosec of x. Sec of x, remember that third letter is what is underneath here, so that's cos x, 1 over cos x. Works the same way. Anytime cos x is 0, which is in these two places, we're going to have an undefined reciprocal function. And then again, it's opposite. So here, instead of being close to 0 or like small to sort of here, we're going to reflect like that. And again, it intersects here and here as well, like that. So it's opposite. Okay, that's our cosec. And the last one I'll do in purple is cot x, 1 on tan x. And for 1 on tan x, again, a similar kind of thing. Now this time where you've got intersections here and here and here, that's when tan x is 0. We're going to have asymptotes again. So in all these places. And again, we're going to actually be doing the opposite here. So here, instead of being small and getting big, it's actually going to go the other way. So it's going to be big and get small. And we can actually intersect here where we had asymptotes before. Okay, the reason for that is before we weren't able to have these values because we would have had infinity, effectively, for tan x. But now, because you've got 1 over tan x, 1 over infinity is effectively equal to 0. So that's an intersection here. Same here. Where we would normally have had infinity, that's why we had an undefined, we're going to have a new intercept. So our function is going to look pretty much like a reverse. Big, and then going all the way down like that. So you've got your reciprocal functions now. The only other thing that's of interest really is just talking about domains and ranges. Now here, because we've got domains restricted, we're between 0 to 2 pi in all of these. For our range, that's where it's a little bit interesting. So for our cosec, and actually what I'll do is just erase this. Oops, get that out of the way. So for our cosec, our range is actually all values that are big, so this way, up until 1, and all the values that are small this way up until -1. So our range is actually going to be all of the negative infinite values, so negative infinity, all the way up to -1 inclusive, union. Now the reason that I'm writing union is because we have to include the other half of that domain. Union, and here we start at 1 and go up to infinity. So that's our range. For sec, excuse me, 1 on cos, our range, you can see here you've got a similar kind of thing, and I actually got rid of that part. So again, it's actually going to be the same. Goes from negative infinity to -1, union 1, up to infinity. So you're not including this region here, effectively. Okay, and I'll actually get rid of this red so you can see. Oops. So now looking at our cot function, you can see that the range is still the same as it is for tan. All you've done is change the shape and changed where the intersects are and where the asymptotes are. So they're your reciprocal circular functions, cosec, sec and cot, and their graphs.